Welcome to the OpenSciEd teacher video series for thermal energy. My name is Chris. I'm an OpenSciEd 6th grade teacher and facilitator, and we are taking a look at lesson 5. And one of the things you'll notice right away is lesson 5 is a little different because the teacher's guide actually suggests you could potentially skip this lesson. But there are some things to consider if you decide to do that. Lesson 5 is different. How much time you spend here really depends on whether you had questions about condensation that came up when you were making your driving question board, or if you actually teach the weather unit, OpenSciEd 6.3, as the core ideas here will come back in that later unit. So you have a lot of things to think about when making a decision whether to use this lesson or to skip it entirely. There is an important sense-making opportunity in this lesson. Kids are encouraged to think differently through and predict the results of an investigation before doing the investigation, and then decide if their ideas were supported or not. So there's a different kind of science sense-making thinking that goes on here. The lesson helps contribute to the storyline by establishing that matter isn't leaving through the walls of cups. In closed systems, nothing goes in or out. There's also an assessment practice moment called cold lemonade on a hot day, which can be valuable. So you'll have to think about those things in deciding whether to use this lesson or to move on to lesson 6. So let's get into it. This video is divided into 4 segments. Briefly, I'll share how we got here in the lesson outline, highlighting key moments. We'll dig specifically into those key moments, and I'll share what's happening and things to look for and be careful of. And lastly, I have a few materials, management suggestions, tips, and tricks for teaching this lesson. So how did we get here? We did lesson 4, which is a big lesson. We redesigned our lid investigation. We modeled in several ways how a lid affects mass loss using drawing and manipulatives. And we figured out a bunch of stuff, like the lids help keep the temperature constant, that open cup systems can lose mass through evaporation, water and air are made of particles, and that we can explain real world events using particle models. Which brings us to lesson 5. This lesson is a one-day lesson, has 2 investigations and 1 formal assessment opportunity, but the basic question we're trying to figure out is, where does the water on the outside of a cold cup system come from? Little side note though, this lesson is not about how condensation works on a particle level. If you go there, this one-day lesson can become a lot longer. So this is a one-day lesson. Although if you want the students to do more hands-on, it can stretch a little bit into 2 days. And the bottom line is they figure out 1 major and 1 minor thing. They figure out that water on the outside of a cup is coming from the air and it's not leaking through the walls of the cup. And that condensation or water droplets tend to collect on a cold surface. This lesson is more about the thinking process than it is about the result. So let's look at a couple of key moments in this lesson. The first one that I identified is in part 2, where they're planning their water droplet investigation. As a little note, the second slide tends to confuse kids a little bit, so I've added a couple additional prompts in addition to those in the teacher's guide, one of which is what tools have we used that might help us out here, or what measurement might be more helpful would we use temperature or would we use mass? But this part of the planning process leads to a shift in their sense making and thinking scientifically, because they're asked to say, if X is true, then we should see Y, or if Y is true, then we should see Z. And that is what they're then going to try to confirm with the investigation. The second key moment here is their first attempt in this unit at doing a transfer task, and it's a good chance to show their thinking to you. I will note on the slide here that I actually add some scaffolds here for both my lower and my higher kids. For the lower kids, I ask them who are they going to agree with and why they're agreeing with that person. And then for my higher level kids, I ask them to do counterclaims too. Like, why didn't you choose the other 2 people who gave you some ideas in the assessment. I will note here too that the teacher's guide literally gives you 5 minutes for this activity. It is just not enough. They definitely need more time to complete this if you want them to do it thoughtfully. Let's talk about some materials, tips, and tricks. Luckily, there's not a whole lot in this lesson for that, because this is in so many ways a standalone lesson. One thing to consider making a note about is what page in their notebook this is on, because if you do teach the weather unit, the ideas that are here and the investigations you do will come back then. Couple of other thoughts. If you're like my school, we have those brown paper towels and they will not work for the investigation. You need white so that you can actually see the color red appear or not appear. I sometimes let the kids do the investigations at lab stations rather than just do them as demonstrations. It's a little bit more hands-on for them. You'll notice also here that the pre-fill options for their predictions are not in the OpenSciEd materials, but I add them there because I think it really helps save some time and helps the kids through a confusion point. You need to be super quick with the first mass measurement because condensation happens quick. And as a last tip, if you're when you are in between or waiting between the two mass measurements, take the cups off the balances, zero the balance, and then put the cup back on. Otherwise, the data can get kind of skewed. The only word we really encounter in here is condensation, and really whatever definition your kids use is fine. This doesn't have to be a super formal definition in this case. And that is lesson 5. And we leave off with a question. If we could completely seal off the cup so no matter can get in and no matter can go out, do you think the temperature of the liquid inside would still change if it was cold water or hot water? And why? Hope you enjoyed. Good luck.